So today we'll be talking about deploying switch-level DLR rings within Converged Plantwide Ethernet reference architectures. So here are some white pages and publications, design guides that are available online through Rockwell that go more in depth than the Tech Talk will. What's covered in these design guides, again, is the DLR device level ring, unsupported technologies, DLR configurations, and DLR troubleshooting. We won't be going that in depth today, but these publications are available for those resources. Today's agenda, we'll just be talking about network topologies as an overview, as well as a DLR overview, and then DLR considerations when you're implementing them into your plant floor. So we're going to start with the overview of network topologies. So this first network topology is a linear topology. It's very easy to design, configure, and implement. And it has the least amount of cabling costs associated with it. So those are some of the advantages that it provides. And then some of the disadvantages it provides is there are a loss of network service in a case of failure because there's no resiliency. So if one node on the network fails, then the entire thing will fail because there's no resiliency. It does have a potential to create bottlenecks with the links closest to the layer 3 devices. So as you're moving up, as you see on the diagram from on the right, if you're moving up from the machine through the switch to the next layer switch, trying to get to the controller or to your distribution switch at the top, it does tend to create bottlenecks because it's a single path, and a varying number of hops make it more difficult to produce reliable performance. Again, that's because it's single point connection, because it's the least amount of cabling that's installed. So while having the least amount of cabling is an advantage on the cost end of implementing, it does come back to hurt you sometimes on the back end with reliable performance. The next network topology is a star topology. Again, very easy to design and configure and implement. Excuse me. And it also has a very low amount of cabling costs associated when you go to implement it as well. However, some of the disadvantages of it is a loss of network service because, again, it doesn't have any resiliency. So if you were to lose connection to any of those devices down on the bottom of the right, then there'd be no way to actually have the network continue to run successfully because there is no resiliency and it's a single point of failure. The next one would be a redundant star. The advantages of this one is it's resilient from connection failure. As you see on the right, that it's as that switch back up, there are 2 connections, so you have some resiliency there because you have more connections to provide for redundancy. It has a faster convergence time if it detects that loss because it can go ahead and switch over to that other connection. It has a consistent number of hops, so it doesn't have that bottleneck effect. So you no longer have network issues where packets getting lost or not being received on time. Disadvantages of it, though, are because it does have that resiliency, there is additional cost in setting it up and with cables, the cable cost, and the configuration complexity because it does get a little bit more complex setting up those additional connection points as which one's going to be primary, which one's going to be secondary for failover in terms of your redundancy. The last one is a ring topology, device level ring. The advantages of that one, it's very resilient from a single connection failure. It has the faster convergence time to the connection loss, and it has less cabling complexity in the plant floor in terms of the star topology. Some disadvantages of it, though, is again, additional configuration complexity. It takes a little bit more time, a little bit more complicated to set up. Has a potential to create bottlenecks. The closer it gets to level 3 devices, so the closer it gets to your distribution and core switches. And it has a varying number of hops. It makes it difficult to produce reliable performance. This next aspect that we're talking about is spanning tree protocol, MSTP. It is a IEEE standard, meaning that it's a standard that's issued by the governing body as far as network devices and applications are concerned. It is available to be used on ring and redundant star topologies. It is a feature set that's built into the Stratix 5400, 5700, and the 5410, as well as the 8000 and 8300. What Spanning Tree does is it provides a loop-free network and redundancy in case of failover. Essentially, what happens is if something starts to produce multiple broadcasts and attempts to create a broadcast storm, the switch that has Spanning Tree enabled on it will detect it, stop it, and won't create any bottleneck or any any failures within that part of the network. It has a distribution in the root bridge. It operates in a plug-and-play fashion. It is something that when Rockwell, when on the Stratix switches, it's not something you have to go in and configure and enable yourself. It's already set and good to go on the Stratix switches that I've already mentioned, so you don't have to configure it. You just plug it in, and it knows to look for those things and to quell them ahead of time. The last bullet says coordinate with IT before implementing it in traditional enterprise environments. Spanning Tree is something that on a traditional enterprise switch you would have to go in and configure. As I said, on the Stratix switch, it's plug and play. It's not something you have to configure. When it says to coordinate with IT, it's as far as letting them know that Spanning Tree is already enabled on that switch. Flex links, this is the Cisco technology. It's only used on the redundant star topology. Again, it's built into the higher performance Stratix switches, 5410, 5400, 5700, and then the 8000 and 8300. It's active standby per the port scheme. It provides alternative path in case of failovers and avoiding loops, similar to similar to the Spanning Tree, where it avoids the loops and consistent broadcast. There's no bandwidth aggregation, so you don't have to designate a certain amount of bandwidth per connection. It's applied to the Stratix access switch, and it's recommended using equal speed ports, and it provides fast failover for multicast traffic, very similar to a Spanning Tree. EtherChannel, it's Link Aggregation Control Protocol, port aggregation. Again, it's another IEEE standard, 802.38d. Again, this is something IEEE is a governing body over network and network applications and helps create the protocols. It's available in the redundant star topology. It's built into, again, the higher performance end Stratix lineup, so the 5410, 5400s, 5700s, 8000s, and 8300s. It aggregates multiple physical links into one logical link, provides resiliency between the connected switches if a connection is broken. So what that means is, where multiple links to one logical, you may have two connections from the switch up, from your access switch up to your distribution switch, but when you look at the actual configuration on the in the web browser, whether that be device manager or the you're looking at it from the command line interface of Cisco CLI, it shows as one logical connection. So even though you have two physical ports plugged in, when you're looking at it logically, it reads them both as the same as one port connection. So we're going to move into the DLR overview. DLR can be implemented in both device level and switch level ring topologies, both seen over on the right. The far right would be your switch ring, and the closer one would be your device level ring. Device level and mixed switch and device level topologies are out of scope with this CPWE. DLR nodes can contain certain roles within, so when you're setting it up, you do set up a supervisor. Now, supervisors are responsible for network loop prevention as well as active and backup statuses. ring integrity, fault recovery, diagnostic, and DLR DHCP server. That's when the setup for the supervisor is on the static switch. If you're setting up a controller to be your supervisor, then the DLR DHCP server would not be available. Also, something you'd set up would be a backup supervisor. So, and then the rest of the devices in the ring would be your participants. So what that means is the reason why you have a backup supervisor is if that controller that you see circled in red on the first diagram, or the switch circled in red on the far right diagram, if that's the device that has the fault, your backup supervisor, which would be the one in yellow, would then detect that that's the device that has the fault, and then send the packet and the information that needs to be delivered the opposite way on the ring, so it wouldn't be halted and you wouldn't see any failure as far as network traffic being delivered, and production would still keep going. You would be alerted that there is a fault on the ring, but your backup supervisor would then take over managing the flow of the loop. DLR ports are not compatible with the following: EtherChannels, network address translation or NAT devices, rep, STP, which is the spanning tree protocol, FluxLinks, 802.1x security, which is an IEEE standard, multiple VLANs, which is set up as VLAN trunking, smart port roles, except for multi-port automation devices. And what this is showing is, as you see over on the diagram on the right, you have an X next to what would be considered your ether channel or your NAT translation, so where that wouldn't, the DLR ring wouldn't be available to be used. And from here, for DLR design considerations, I'm going to pass this off to Joe Boleski.
Thank you. I think I'm going to let you drive on this one. And
okay.
Next slide, please. So we have a whole bunch of in-depth design considerations to talk about when it comes to device level ring. If you have any questions, please put them into the chat or the Q&A, and we will try to answer them as we go along. So one of the main things, device level ring is a single fault tolerant system. And so within the device level ring network, since you're building a ring, network capacity is a critical metric. And you really want to kind of understand what your bandwidth is going to look like on that network. And for our smaller device level rings, that's typically not a problem. This isn't really even an issue until we hit the larger networks where we try to start talking very, very quickly, like 1 millisecond, 2 millisecond packets. So one of the main considerations is going to be having too many devices on your network. On a typical device level ring, we have always limited it to 50 nodes to guarantee the throughput. And on the some of the newer device level ring capability, where we can do switch level device level rings, we can go much higher than that. And so one of the other pieces down at the bottom, you can see some of the different testing metrics that were used as part of the testing that Rockwell has done on the different networks. Next slide, please. So when we look at the different architectures that are supported, and there's multiple different ways of doing this, and basically we can do up to 24 switches per device level ring, and so introduce more risk, obviously. One of the main considerations there is to limit that to 254 hosts per device level ring. So that is going to be your standard Class C style network address range. And so the network capacity is one of the things that we do try to manage there. And one of the other pieces when you look at these device level ring networks is that we are limited to a single VLAN. Next slide. So within the architecture, you can look at all that. We have this nice documentation out there to let us know what our limits are on DLR and so on. And we have different ways of doing some of the uplinks. And so with that, we can get to a second. I was having a network issue here. So one of the main things when we're looking at the uplinks is how the technology that we want to use going out of the device level rings when we're talking from switches to that next level of stacked switches. How do we want to talk there? And one of the main ways that we typically do that is going to be through flex links. And so later on, you'll see the different testing that was done, and the preferred method is flex links there typically. And we do offer a few different ways of getting out of a device level ring for resiliency, where we have a redundant gateway functionality. There is a note here on this page about the redundant gateway. Multicast traffic does have some longer convergence times when it comes to failover on a redundant gateway. So something to keep in mind if you're looking at implementing that technology. Next slide, please. So as I was saying, we can do up to 24 switches, and within there we can have a mixture of Stratix 5400s and 5700s. And the one main thing to keep in mind is you do not want to mix and match 100 meg and gig speeds. So can you do it? Yes. Should you do it? Definitely not. The main thing there is you are creating bottlenecks in your network, and is with any other ring, a break in the ring can happen at any location. And so don't try to architect your system so that you have gig in one part and not in others, because a break in a link would result in everything going through that 100 meg section and could create bottlenecks and some traffic issues. So very important to make sure that your speeds are all the same. And then again, single VLAN. Next slide. So one of the things that we can do is have a single, you are limited to a single VLAN per ring, but we can have that VLAN span multiple rings. So if you look at the picture on the left, VLAN 10, that actually is spanning multiple rings that are going up and down through the stacked switches, where the other rings off to the right, VLAN 20 and 30, are individual. So it does allow you to be able to do different pieces there. And basically you want to keep your speed consistent within a ring. So if you're spanning multiple rings, you could effectively have different speeds there. But again, within a ring, you definitely want to have the speed be the same. And at this point, there really isn't an issue with mixing and matching the Stratix 5400s and 5700s. Next slide, please. So you can see some of the testing that was done. And so Rockwell has gone through and tested different combinations of distribution switches, the redundant star and different types of stacking protocols, and has looked at what works best, what's validated, what's not tested, and what is not validated. So you can kind of see a hierarchy there. And this is some of the in-depth detail that go into some of these documents, including some of the explicit test results and aggregate test results, so that you can make your own decision as to, where we've validated multiple different configurations when it comes to stacked 3550s, and understanding why you would choose one over the other. Next slide. So unsupported technology, unsupported topologies, the DLR, it does not support sharing the same ring between two nodes. So basically you're creating multiple rings here when you look at this by having that switch stuck in the middle. This isn't to be confused with having the Stratix 5400, which can have multiple rings. So in this case, you put a Stratix 5400 in the middle, you could have a ring 1 and a ring 2. The problem, again, still is we're creating a third ring with the stacked switches. So still not a valid topology, regardless of which switch we would use there, because of the because of the interconnection to the stacked switches. Next slide. So a couple of the other pieces is limiting the protocols that are used. As you can see, we only support device level ring on the device level ring ports. So when you're talking up to the switches above, you need to be using on your uplink ports the protocols required for those, but you can't intermingle device level ring and STP or rep or any of those other protocols. And so that is one of the main functions there. So there are a limited number of ports you can use on our static switches for device level ring. And you want to make sure that you use those appropriately, but not try to use a port for two functions. Next slide. So one of the other pieces is our embedded switch technology is basically, when you think about it, is a linear topology. Every packet that comes in one side goes out the other, unless it's supposed to end there. And that results in basically this drawing off to the right where you now have created a ring. You may have not have meant to create a ring, but you've created a ring. And so as a result, without having device DLR turned on, you now have made a loop in the system, so it's not a valid network architecture, and you start creating packet storms very quickly. So something else to try to avoid when it comes to implementing, using our DLR devices. You want to make sure that you're using a DLR properly. Next slide. Similarly, the DLR, you can come out through an ETAP up to the network. What isn't supported is using two ETAPs to try to create that redundant gateway uplink. We can do redundant gateway with the 5400s, but we cannot do it with an ETAP functionality. So to make this be a valid system, you would remove one of the ETAPs from the uplink, from it having an uplink to the switches. So, thank you. In two separate linear configurations, you can combine those to try to create a device level ring, but you need to take extra precautions there, because as you can see, we have on the left a STP or rep connection between the switches. We do not have a DLR link between the switches. So when we create and connect those two different linear networks together, we are now creating a different convergence method, which is not device level ring, which can cause all sorts of different issues. You basically have an unmanaged network at this point when it comes to the failover and reconvergence, and possibly very extended times if you actually do the connections and reconnections where your network would be down. So something to avoid. You want to make sure you have the switch infrastructure set first before you create that last link. Next slide, please. Similarly, on a single linear network, you can create the same functionality. Is adding that extra port, extra cable, and you've now made a loop in the network that is now going to cause packet storms and things like that the system would have to try to automatically filter out and wouldn't really know what to do with. So again, if you added in an additional DLR link in between those switches and made this a separate DLR, that would make that a valid topology. Next slide. So in summary, basically we're limiting from the commercial engineering side, we're limiting to 24 switches. That's really what we've tested at this point. And so traffic loading is one of the main pieces there that we want to watch, and checking capacity. And off of all of these switches, we're looking at different star topologies and stuff out to your end devices. And so we want to try to limit the number of end devices to 254, basically a Class C network. And we're also limited still to one VLAN on a network. Redundant gateways are available and have been used and shown to work very well. The main thing there is you want to read through the documentation before you implement them, because of some of the multicast and other PTP type and SIP-sync issues that have come up with those. Multiple segmented rings, it was tested for scalability. So you can try to break apart your different networks as needed. And so a lot of that has been tested and has been put into the different documentation. And test results are for both reference architectures are consistent with the CPWE. So we've done a lot of testing on different redundant star topologies for the next level up and different resiliencies. And so we've done an awful lot of different things at that. Were there any questions? I ran through that pretty quick. I figured there'd be a question or two. So one of the main things with the device level ring is that it is single fault tolerant. So once something does fail, whether it be a link or a switch, you're still left with a linear ring. It's important to make sure you pull diagnostics off of that so that you know you have failed to a linear system, so that you can go in and repair. And that's one of the main gotchas, is you have to go in and repair it, as if you don't go in and repair it, eventually you'll end up with a second failure. That eventually could be 10 years down the road, but eventually will happen. If there aren't any questions, thank you for your time. We will be doing more of these, and I hope you found this useful.